Hello, and welcome to my presentation about progressive system platforms and components for advanced process spectroscopy. My name is Christian Lux, I'm Business Development Manager at TEC5, and I will guide you through the next couple of minutes. TEC5 is a manufacturer of industrial-grade spectrometer systems and components for process analytics since 1993. The TEC5 group is represented globally. Our internal sales partners serve their respective regions directly with intensive support from the headquarters. Moreover, TEC5 is present in key regions like USA and China with own subsidiaries. We make use of optical spectroscopy as it is one of the most versatile, flexible tools in modern process analytical technologies. Our solutions for PET are already widely used in manufacturing and processing industries, for automatic physical-chemical analysis of raw materials, intermediate and final products. Optical spectroscopy is a well-proven and established PAT method for fast and non-contact measurements, and our dedicated spectrometer and photometer systems are used in manifold applications. Our spectrometer systems are ideal solutions for 100% inspection in real time, covering almost the complete production process, from incoming goods inspection to process monitoring and final product release. Thus, the continuous monitoring of measurement data allows to ensure product quality, to optimize production processes, and to comply with relevant regulatory guidelines. Today's focus will be on our smart sensor solutions, providing a progressive system platform and components for advanced process spectroscopy. Until now, most of you might know spectrometers as tabletop or lab analyzers, or even process systems where the spectrometer itself is connected to a PC, which is in turn communicating with a PLC. But how can a smart sensor be defined? In contrast to classical PC-based spectrometer systems, embedded smart sensor systems offer low-level, real-time implementation of the entire data processing, including chemometric evaluation directly in the measuring instruments, meaning that the relevant components, spectrometer, light source, data processing board, are integrated in one unit. Today's smart sensor concepts are available as compact devices due to their autonomous, real-time operation and simple possibilities for connection to process control systems or networks. They represent the basis for modern process analysis technology, especially in the connection with strategies such as Industry 4.0. The generic embedded platform is compatible to a variety of sensor heads and probes, which are available as immersible probes, distance or contact sensor heads, and flow-through cells. Due to autonomous operation and remote method management, these smart sensors can be used for continuous processes and for batch processes as well, operating, of course, 24/7. The kind of production process, the chemical and physical composition of the sample under investigation, is essential as it has an impact on the selection of the proper wavelength range and the technology to be used respectively. Our platform offers a multitude of spectral ranges, from the UV-Vis to the NIR, but also for Raman spectroscopy. Different grades of standard detector types allow to configure high-end performance, as well as compact and cost-effective smart sensors based on, for example, MEMS technology. A subsequent evaluation of the measurement spectra via univariate or multivariate analysis is performed on the device and delivers, for example, the concentration of specific ingredients in the product matrix. Many standard MVA software packages, such as Chemo Unscrambler, Sensor Logic Predictor, Geometrics by Simca are supported. In some instances, a simpler way of data evaluation is sufficient to serve the application. Our built-in formula parser will help you to also realize such applications in an easy way. A wide range of different hardware or software interfaces, for example Modbus TCP, EtherCAT, Profinet, Profibus DP, CAN bus, OPC, and furthermore, are available for the connection of our smart sensors to the process control system. Thus, the device transmits fully prepared analysis results in real time and in conjunction with all relevant sensor status information to the process control system or even to a cloud-based network. In this example, a UV-based smart sensor in liquid phase is used. The interface to the process is a fiber optic coupled immersible probe. UV spectroscopy is an extremely sensitive and specific detection method, which is typically very high extinction coefficients. Measurements even at very low concentrations are feasible. In this application, pharmaceutical separation and purification process, the concentration range has been far below 1%. Here, a full chemometric data analysis has been applied, and the results were transferred in real time via 420 mA interface. Spectroscopy is a generic appliance technology, and therefore not limited to specific applications or industries. Smart sensors can be found in the most varied production processes as inline and online analysis system, for mobile use in harsh environments mounted to vehicles, or as handheld device, where you go by using a battery-driven, lightweight system with the ability to monitor spectra and results in your hand. Innovative smart sensing technologies from TEC5 open new opportunities for riskless process analytics, therefore making them a powerful tool for PAT in many applications. The benefits in regards of the use as a PAT tool over any conventional offline analyzer are numerous. To mention a few of them: product quality, meaning a precise production according to a defined property profile. This guarantees and specifies 100% controlled quality. It is cost effective, enabling a cost-efficient production through the optimized use of resources and material. It allows time saving, which is the elimination of the time-consuming sampling from the offline process and laboratory analysis. Low maintenance, including preventive and predictive maintenance, which further enable a reduced downtime, of course with the aim of an increased yield due to the measurement-based optimization of production processes and efficient use of resources, and with the aspects of safety and environment, by reduction of safety risks and low environmental impact. If you would like to find out more, please check out on our website or follow us on LinkedIn. My colleagues and I are looking forward to talking to you. Thank you.